This shape right here, as we saw above, is the side of a wing. This shape is also referred to as an airfoil. And an airfoil is any structure that produces lift. Alright, so this can be wings, propellers. Let's talk about the different parts of a wing, or different parts of an airfoil. The most forward part of an airfoil is called the leading edge. The most rearward part is called the trailing edge. This curvature that we have right here, this is called the camber. And then lastly, if we were to create a line that connects the leading edge of the wing all the way to the trailing edge of the wing, you would call this the chord line. Alright, so these are some terms that we must know as we proceed forward. Let's talk about how lift is actually created. So the correct theory of lift is the addition of two different theories. The first one is called the Coanda effect, and the second is Newton's third law of motion. The first one we're going to talk about is the Coanda effect and how that applies to lift. And for that, I ask you to make an experiment at home. I want you to grab a candle, light it up, and then a bottle, a cylinder type bottle. And I'm going to draw this bottle as viewed from above. Alright, and what I want you to do is I want you to place this bottle just a few inches away from the fire created by the candle. And what I want you to do is that I want you to blow on the other side of the bottle. Normally we would think, okay, well, you know, I'm not going to be able to extinguish the flame because the airflow is going to hit the bottle and it's going to go away. It's going to get deflected away. The interesting thing is that it doesn't. It actually follows the curvature of the bottle, and you will see that you will be able to blow or extinguish the flame. And that is due because of the curvature of the bottle. As the particle of air approaches the bottle, it takes a curvature, alright, and it doesn't deflect away. Because in order to take this curve, there should be more pressure, so I'll just put here a higher pressure on the top and a low pressure on the bottom. The high pressure acts downward and it pushes the particle towards the surface of the bottle. Okay, this, my friends, is called the Coanda effect. Because the wing is also curved, the same thing happens to it. The introduction of a wing makes the flow of air curves. Beforehand it was straight. Now it curves. It takes a curve that follows the surface of the wing. And this flow gets deflected up and down following the surface of the wing, and it creates lift. It causes lift. How that works? So, far away from the wing, or from the airfoil, we have atmospheric pressure. So I'll call this atmospheric pressure A and atmospheric pressure B. We know that in a curved flow, the outside pressure is greater than the inside pressure. So we have a higher pressure on top, a low pressure on the bottom. So we know that pressure out is greater than the pressure in. At the top, right here, the pressure decreases as it moves towards the airfoil. On the other hand, at the bottom, pressure actually increases as it moves towards the airfoil. This differential pressure, this lower pressure on top and this high pressure on the bottom, is what causes lift. So in summary, we introduced a curved surface into flow of air. It curves the flow of air. Now we have outside pressure high, inside pressure low, and atmospheric pressure as it goes towards the airfoil, it decreases. The one on the bottom, conversely, as it goes towards the airfoil, it increases, as we can see here. In this differential pressure created by the high pressure on the bottom and low pressure on top basically produces the force that we know as lift. More curvature, more lift.